Check your calendar. It is 3 days to the WAEC 2026 practical chemistry. And I have one more shot. And if this is your first time in this channel, go back and watch all my videos pertaining this chemistry practical. Now, in every experiment, either as a teacher or as a student, error is inevitable. But you can make an effort to limit the error. Now, students always find themselves in the net of this error, especially in titration experiments. This error is called the parallax error. In this video, I'm going to explain 3 things about parallax error. Number 1 is the meaning of parallax error. Number 2 is the mechanism that leads to parallax error. And then number 3, how to avoid it. So watch as I explain everything step by step. Now, the meaning of parallax error. Before I explain the meaning, I want to talk about something. If you pour a clear liquid inside a test tube, there is a surface. For some liquids, this surface is concave. For some, it is convex. This surface in titration terms is known as meniscus. Now, if you want to read your burette reading, your eye must go to the lowest point on the meniscus. If for anything you could not detect the lowest point on the meniscus, the number there, and you detect an unreal value, you commit an error due to parallax. So parallax error is the unreal value or the artificial burette reading you get as a result of looking at the lowest point of meniscus from an angle. That is parallax error. Now let us talk about the mechanism of parallax error. These are the things that lead to parallax error. 1. This is a student viewing this lowest point. This is another student viewing the same lowest point. And this is another student viewing the same lowest point. These 3 students will never get the same burette reading because of parallax error. Now look at how it happens. If you are taller than the burette, sometimes I see students performing titration and I laugh because the burette will be very high like this and you are very short. Sometimes the burette will be arranged this way and you are very tall. Now, if you are taller and you are viewing this point like this at an angle, the first place that the line of sight hits before it reaches this lowest point of the meniscus is the value that your eye will detect. So if you are viewing from this angle, you are going to see a value that is lower than this real value that is 12.5. That is 12.30. This is a graduation, and you know that this sight line hits the burette at upper part, which means the number that you will see is the number that exists before the real value that is 12.50. And then this student is going to record 12.30 instead of 12.50 with a difference of 0.2. Here is another student, a shorter student, viewing from this angle. You know that where the line exists is at the bottom of the meniscus. But the sight line hits the burette at a lower end, which means the observer is going to see this number that is beyond the real 12.50. And the number is greater than 12.50, which is 12.70, difference of 0.2. But if you position your eye in a way that it is perfectly horizontal to the lowest point of the meniscus, like here, your sight line is going to hit exactly the point of the burette that coincides with the lowest point of the meniscus, and you will get the real value, 12.50. If you view from up, you get a wrong value. If you view from down, you get another wrong value. But if you position your eye to be perfectly horizontal to the lowest point of the meniscus, you are going to get the real burette reading. And that is the mechanism of parallax error. Finally, how do we avoid parallax error? Number 1, level your eyes. If you find out that the lower meniscus is existing up or down, you see this setup does not bite. Carry the setup, position it at eye level and take your reading. That is how to position your eyesight. Number 2, read the bottom of the meniscus only. Don't go and read the top of the meniscus. You will get a wrong result. There is an exception to this rule. If the liquid inside is colored, that you will not be able to see the lowest point of the meniscus, then read the up. As far as your values are consistent and concordant, there is no issue. Another exception, if the liquid has a convex meniscus, then read the highest point on the convex meniscus. Number 3 rule, use a reading card. It's a white sheet of paper with a black line on it. You place it at the back of the burette. Arrange the line in a way that it will coincide with the meniscus line. This will darken the meniscus and make the visibility clearer. And finally, make use of digital burette. In instrumental chemistry, you are advised to use digital devices like digital burette. If you use digital burette, anything pertaining to parallax error will be eliminated. If you found this video useful, click on like, comment, share the video, tag your friends, follow and subscribe to my YouTube channel.